In this video, we're going to take a look at exam revision for equations and quadratic inequalities. So all we're doing for this video is just consolidating everything we've covered so far for equations and quadratic inequalities by taking a look at some exam style questions. So do check the previous videos if you feel like you need a bit more revision, but if not, let's take a look at the first question here. Taking a look at the very first question here, then we're asked to solve the following simultaneous equations. So I've got x minus y minus 4 is equal to 0, and then 2x squared minus x plus 3y is equal to 0. So to begin with here, what I'm going to do is I'm going to call this first equation, equation 1, and my second equation here, equation 2. Now what I need to do is rearrange equation 1 so that either x is the subject or y is the subject, and substitute that into equation 2. Now if we just have a think about this, which one is easier to substitute? In this case, it will be y equals. And the reason for that is because equation 2, I've got 2x squared minus x, so if I substitute x in, it's a little bit more complicated. You can still do it, just a little bit trickier to work with. Whereas if I just substitute y in, it's just 3 lots of y. Okay, so if I rearrange equation 1 here, so that y is the subject, that's just going to be x minus 4 is equal to y. Or in other words, y is equal to x minus 4. Okay, now I'm going to substitute this into equation 2. I'm going to get 2x squared minus x and then plus 3y, where y is equal to x minus 4. So plus 3 lots of x minus 4 there. And we know all of this here is equal to 0. Okay. So if we just simplify here, I'm going to get 2x squared minus x, and then we get 3x here, just expanding this bracket. So plus 3x, and then 3 times minus 4, giving me minus 12. And that's all equal to 0. So if we just simplify here the left-hand side of this equation, I'm going to get 2x squared. So 2x squared, I've got minus x plus 3x, that's 2x. And then we've got minus 12 here, which we can't do anything with, so it's just minus 12. And that's all equal to 0. Now the first thing I notice here is everything is a multiple of 2, so I can divide straight through by 2 here. So dividing through by 2. Dividing through by 2 here. Again, you do it on the same, on the right-hand side as well. Obviously, 0 divided by 2 will still give you 0. So if we go through here, I'm going to get x squared plus x minus 6 is equal to 0. Okay, so that's a 0. So now what we're going to do here is check whether this factorizes. And in this case, it does. I'm going to get x plus 3 here times by x minus 2. Okay. You could have factorized at this point here if you wanted, but I think it just makes it more straightforward to just divide through by 2 and then go into the factorization there. So from here now we get 2 solutions for x. So in that case then we get x is equal to minus 3 here. So obviously each one of these would be set equal to 0. So x plus 3 is equal to 0. That would mean x equal to minus 3. So x equal to minus 3. And then we get positive 2 there. Okay. Now we're not finished here because I need to identify the respective y solution for each individual x solution here. So in that case then, when x is equal to minus 3, I now need to substitute when x is equal to minus 3 into my equation for y here. Okay, so y is equal to x, which is minus 3 minus 4, giving me minus 7 there. Okay, so when x is equal to minus 3, y is minus 7. And then when x is equal to positive 2, I get that y is equal to 2 minus 4. So 2 minus 4, giving me minus 2 there. Okay, so our solutions here is x equals minus 3, y is equal to minus 7, and we also get x equals 2, and y is equal to minus 2 there. Okay, and there we have it, so that's our solution to that question. Taking a look at question 2 now, we're asked to find the set of values of x for which x squared minus 4x minus 21 here is greater than or equal to 0. Now the actual quadratic inequality here is pretty straightforward. The only thing that might complicate this question here is that we need to give the answer in set notation. But we'll worry about that at the end. So to begin with here, how do we solve a quadratic inequality? Well, all we do to start with is we factorize. If I factorize this quadratic here, I'm going to get x minus 7. So x minus 7. And x plus 3. Okay. Now what I need to do now is just do a quick sketch of this quadratic here. Okay, it doesn't have to be perfect, but just so we can see what we're looking at. So that's my y-axis, and this is my x-axis here. Okay. So it's going to cut through at 2 points here. It's going to cut through at -3, so x equal to -3, and x equal to +7. Okay, so +7 as well. So we say that's -3 there, and we have 7, say, here. Okay, and it will cut through the y-axis here at -21. Okay, and I'm going to say that is roughly there. Then what I'm going to get is a quadratic that looks something like this. Okay, I'll say 7's there instead. It's going to look something like that. Okay, again, it's not perfect, but you get the idea. Now we're looking for where this is greater than or equal to 0. So in other words, where is this above the x-axis? Well, there's two regions for that. So if we do this in a different pen color, I've got the region here. So everything to the left of -3 and everything to the right of +7 there. Okay. So how we normally present that solution here would be x is less than or equal. So we include the same sign here. So if it's greater than or equal, we need to include the equals here. So x is less than or equal to -3, anything smaller than -3 essentially, and then anything greater than or equal to 7. Okay. So x is greater than or equal to 7. But this isn't set notation. Okay, so we need to give this in set notation then. So using set notation here, and the way I need to present my solution is we'd say we have the set here for x. So x such that x is less than or equal to -3. Okay, so that's part of our solution. So that's this part here. But then don't forget we also have anything greater than or equal to 7. So we need to use the union here. Okay, we've got the union. And then we have the set here for x such that x is greater than or equal to 7. Okay. Now that's an important skill. We don't always have to give the answer in set notation, but sometimes you will be asked to give an answer in set notation. So do make sure that you do know how to use set notation. It's a very easy mark to drop if you don't know how to use it. Okay. So there we have it. So that's our solution to question 2. Taking a look at question 3 here, we're asked to solve the following simultaneous equations. So I've got x minus 2y is equal to -4, and then I've got x squared minus xy is equal to 6. So how do we solve this here? Well, again, we're just going to use substitution. So I call this equation 1. I call this equation 2 here. Then what I need to do is I need to rearrange equation 1 and substitute that into equation 2. So I'm going to make either x the subject here for equation 1 or make y the subject. Now it's completely up to you which way you do this, whether you make x the subject or y the subject. In this case, I'm going to make y the subject because I only need to substitute into this place here, this minus xy. Okay. If I was to make x the subject, then I need to replace x squared here with my bracket here. And then I'll do the same here, so minus xy. Okay. So rearranging this here, I'm going to get x plus 4 is equal to 2y, and I'm going to divide through by 2. Okay, so in that case, then we get y is equal to a half x plus 2. Okay. Now straight away we can see we're going to get a bit of an issue here because I've got a half x. When I substitute this in a moment, it's going to get a little bit, not nasty, but it's not quite as straightforward as the previous examples. Okay. So let's substitute this here now into equation 2. Okay. So in that case, I'm going to get x squared. Then I get minus xy here. So if y is a half x plus 2, we get minus x lots of a half x plus 2. Okay, and that's all equal to 6. That's equal to 6. And what I need to do now is just obviously expand this bracket here. So I'm going to get x squared minus x lots of a half x. That's going to be minus a half squared. So minus a half x squared there. And then we're going to get minus 2x there. Okay, so I get minus 2x, and that's all equal to 6. So what do I do now? Well, I just need to simplify the left-hand side here to begin with. So I've got 1x squared here minus a half x squared. So in total there I've got a half x squared. So we've got a half x squared. I've then got minus 2x, and that's all equal to 6. Now, when I go to solve this quadratic here, I don't want it to be equal to 6. I want it to be equal to 0. So what I'm going to do here is I'm going to subtract 6 off both sides. So we get minus 6 is equal to 0. Okay. Now it's up to you. You could use the quadratic formula at this point here. Obviously a will be a half, b will be -2, and then c will be -6. You could do that here. If you wanted to, you could try and get this to solve by factorising. Now at this point here, I don't want to try and factorise it like this. Obviously I don't want to try and factorise with this coefficient here of x squared being a half. So what I'm going to do is I'm going to multiply through by 2 here, so that the coefficient of x squared is 1. Obviously make sure that you times everything through by 2, okay? So if I times everything through by 2 here, do the same on the right hand side as well. Then I'm going to get x squared, so we get x squared there, minus 4x, so minus 4x, minus 12 is equal to 0. Okay, 0 times 2, clearly we just get 0. And what I want to do now is check whether this factorises here. Okay, so does this factorise? Well, let's just double check. So I'll get 2 brackets. I'll have an x at the front of both of these brackets here. So 2 numbers at times give me minus 12, but we'll add to give me minus 4 here. So in that case, this would factorise. I'm going to get minus 6 and plus 2 there. Okay, minus 6 times 2, minus 12, and then minus 6 plus positive 2 here would give me the minus 4. So this is equal to 0. So from here now I can get my 2 solutions for x. So in that case, x will be equal to, so I've got x minus 6 equal to 0. In that case, I'm going to get x equal to 6. So x equal to 6. And we've also got this solution here. When x plus 2 is equal to 0, then I get x equals minus 2. Okay. So what I need to do now is find the respective y solutions here by substituting back into this equation here. Okay, y is equal to a half x plus 2. Now I could substitute back into this equation 1 here, but since I've already rearranged it so that y is a subject, just substitute back into this. Okay, so y is equal, so let's just do this for when x equal to 6 first. So when x equals 6, then I get y is equal to a half of that, so half of 6. So half of 6 plus 2. So in that case, I'm going to get 3 plus 2, giving me 5. And then we do the same when x equal to minus 2. So when x equal to minus 2 here, I get y is equal to a half of minus 2 plus 2. So in that case, I'm going to get minus 1 plus 2, giving me 1 there. Okay, it's the same as doing 2 minus 1, giving me 1 there. Okay, so I can see then that my solutions here are x equals 6 and y is equal to 5. And then I've got x equals minus 2 and y equals 1 there. Okay, and there we have it. So that's our solution to that question. Moving on to question 4 now, where we're asked to find the set of values of x for which, and then we have 2 parts. So in part A, we're looking for the set of values of x for which x squared is strictly less than 4 minus 3x. So in this case, what I want to do is get rid of this right hand side here. We want to make that 0. So I'm going to add 3x to both sides and then subtract 4. So I'm going to get x squared plus 3x and then minus 4. And that's going to be strictly less than 0. Okay. Now from here we want to check whether this factorizes, and in this case it does factorize. So we're going to get x plus 4 and x minus 1 there. Okay. Now from here we always sketch our quadratic. So if I just put my axes on here. Okay. And say it's going to look like this. So that's my x-axis. This is my y-axis. So it's going to cut through the x-axis here at minus 4. So minus 4 and positive 1 there. Okay. So if I say that's minus 4 and that's 1, and it will cut through the y-axis here at minus 4. Okay. Let's say that's there. So if I join all of this up here, we're going to get something that looks kind of like this. Again, it's not perfect, but just so we can see what we're looking at here. If I call that 1 there, okay, that's my quadratic. Now we're looking for where this is strictly less than 0. So where is this below the x-axis? So if I shade this on here, we have this region here between minus 4 and 1. Okay, so that's our solution to A. So if I just present the actual solution here, then we're going to say that x is between minus 4 and 1. Okay, notice that our inequality here matches what we started with in part A. So that's the solution to part A. Let's have a look at part B now. So for B here, it says we need to find the set of values of x for which. So notice we've got the quadratic inequality from part A. So that's part A there. But then we've got this extra inequality here. Now this is a linear inequality, so it shouldn't be too bad. So let's solve that to begin with. I've got 3 lots of x minus 1, and that's strictly greater than 2x minus 5. So to begin with here, I need to expand this bracket. So I'm going to get 3x minus 3 is strictly greater than 2x minus 5. So if we take this over here, I'm going to subtract 2x off both sides here, take the smaller amount of x onto the other side. So I'm going to get x there, minus 3 is greater than minus 5. And then I'm going to add 3 to both sides here. So I'm going to get x is greater than minus 2 there, or strictly greater than minus 2. Now, we need to consider the overlap here between our solution here of minus 4, or x lies between minus 4 to 1, and then this solution here for this inequality of x being strictly greater than minus 2. Okay? If we think about a number line, so let's do this in a different pen colour here. Okay, so we had, this is for x here. So, if I say this is 0, if I've got minus 4 here, say down here, to 1, then that would be this inequality here. Okay, so I'll do that one in red. So that's my inequality there. But then I've also got this one here. If I do that in blue, okay, I do this one in blue, where x is strictly greater than minus 2 here. So this is, say, minus 2, and we go from here upwards. Okay. So in that case, then we can define our new inequality here, where the overlap is between minus 2 and 1. Okay, notice where they overlap between minus 2 and 1. So I'll do that again in one more colour here. Let's do that in green. So minus 2 to 1 there. Notice that's where they overlap. So in that case, then my solution for B here is going to be strictly between minus 2 and 1 there. Okay, that's where both of those inequalities are satisfied. Okay, and that gives the solution to question 4. And finally, taking a look at the very last question here, we're asked to find the set of values for which 3x squared plus 7x plus 10 is strictly greater than x squared plus 2x plus 8. Again, we just need to give the solution here in set notation. And to begin with here, what I'm going to do is I'm going to take this right hand side here of this inequality. I'm going to take that all to the other side. So I'm going to subtract x squared, positive 2x and positive 8. Okay, so what that would do there is it would make this right hand side here 0. So 3x squared minus x squared, that would give us 2x squared. I've then got 7x minus 2x, that would give me positive 5x. And then finally 10 minus 8 giving me positive 2 there. Okay, and this is all strictly greater than 0. And from here now, this should be hopefully pretty straightforward to solve this quadratic inequality. So what I need to do to begin with here is factorize. I'm going to factorize this quadratic here. So in that case here, I'm going to get 2x plus 1. So 2x plus 1 times x plus 2. Okay. Now again here, what I need to do is I need to sketch this quadratic here. Okay, so now that we've factorized it, we can easily identify the solutions. We've got a solution here of x equals minus 2 and minus a half. Okay, set both of these equal to 0 and you can see where the solutions are, where it will cut through the x-axis. So that's going to be minus a half there. Okay, so that corresponds to 2x plus 1. So we quickly sketch this now. That's my x-axis there. That's my y-axis. So like we said, it cuts through at minus 2, and minus a half. Okay, let's say there. Now, this will cut through the y-axis at positive 2. Let's just say that's there, for example. So if we join all this up here, we're going to get something that looks like this. Again, my quadratic here is pretty awful, but you get the idea. That's a pretty bad sketch. Let's try it one more time. Let's try one more time because that's not very good. So if I try one more time here, I think what might make this a bit easier if I just bring that 2 down a little bit. In fact, if we bring it up a little bit, might make that a bit easier. So if I just join that up again, there we go, that looks a bit better. Okay, so that's my quadratic here. Now we're looking for where this is greater than 0, so where this is above the x-axis here. So if I just extend my x-axis here, then there's 2 regions. So again, if I just change my pen color to highlight this here, in fact, we'll do it in red again. Then I've got everything to the left here of minus 2, but not including minus 2. And then everything to the right of minus a half, but again, not including the minus a half. Okay? So if we go straight to giving the solution here in set notation, then what we're going to say is we have the set x here, such that x is going to be strictly less than minus 2. Anything smaller than minus 2 there would satisfy this inequality here. So strictly less than minus 2. And then we have the union, because we also need to include this solution here. Have the union for the set here of x, such that x is going to be strictly greater than minus a half there. Okay, so strictly greater than minus a half there. Okay, and there we have it. So that's our solution to that question. And that brings us to the end of this video on exam revision for equations and quadratic inequalities.